Computer Information System Modeling. As it was mentioned in the introduction, we decided to analyze the SIS from the business service point of view. Generally speaking, users of the system are generating tasks which are being realized by the SIS. The task to be realized requires the services presented in the system. A realization of the system service needs a defined set of technical resources. Moreover, the services has to be allocated on a given host. Therefore, we can model SIS as a four-tuple, Wakowiak, 2009. During modeling of the technical infrastructure, we have to take into consideration functional aspects of SIS. Therefore, the technical infrastructure of the computer system could be modeled as a pair, where H set of hosts, computers, in computer network. We have assumed that the aspects of TCP/IP traffic are negligible, therefore we will model the network communication as a random delay. Therefore, the niche function which gives a value of time of sending a packet from one host, vi, to another, vi. The time delay is modeled by a Gaussian distribution with a standard deviation equal to 10% of mean value. The main technical infrastructure of the SIS are hosts. Each host is described by its functional parameters. Server name, unique in the system. Host performance parameter, the real value which is a base for calculating the task processing time, described later. Set of technical services, i.e. Apache Web Server, Tomcat, MySQL database. Each technical service is described by a name and a limit of tasks concurrently being executed. We have distinguished a special kind of technical service which models a load balancer, Aya et al., 2002. A load balancer is described by its name and a limit of tasks, like all technical services, and additionally by a list of technical services it sends requests to. The BIS is a set of services based on business logic, that can be loaded and repeatedly used for concrete business handling process, i.e. ticketing service, banking, VoIP, etc. A business service can be seen as a set of service components and tasks, that are used to provide service in accordance with business logic for this process, Michalska and Wakowiak, 2008. Therefore, BIS is modeled as a set of business service components, BSC, i.e. authentication, database service, web service, etc., where each business service component is described a name, reference to a technical service and host describing allocation of business service component on the technical infrastructure and a set of tasks. Tasks are the lowest level observable entities in the modeled system. It can be seen as a request and response from one service component to another. We have distinguished two kinds of task, local and external. If request is sent to service component and this component is able to respond without asking other service component, then this task is assumed to be local. If request is sent to service component and this component must ask another service component for response, then this task is assumed to be external. Each task is described by its name, task processing time parameter, and in case of external task by a sequence of task calls. Each task call is defined by a name of business service component and task name within this business service component and timeout parameter. System configuration, conference, is a function that gives the assignments of each service components to a technical service and therefore to hosts, since a technical set is placed on a given host. In case of service component assigned in a configuration to a load balancing technical service, the tasks included in a given service component are being realized on one of technical services, and therefore hosts, defined in the load balancer configuration. The client model client consists of set of users where each user is defined by its allocation, host name, replicate parameter, number of concurrently running users of given type, set of activities, name and a sequence of task calls, and interactivity delay time, modeled by a Gaussian distribution. Task and business services interaction. Summarizing, a user initiate the communication requesting some tasks on a host. It could require a request to another host or hosts. After the task execution, host responds to requesting server, and finally the user receives the respond. Request and response of each task gives a sequence of a user task execution as presented on exemplar figure 1. The user request execution time in the system is calculated as a sum of times required for TCP/IP communication and times of task processing on a given host. The request is understood as correctly answered if answers for each request in a sequence of a user task execution were given within defined time limit. Timeout parameter of each request in BIS model, and if a number of tasks executed on a given technical service is not exceeding the limit parameter of TModel. The user request execution time in the system is calculated as a sum of times required for TCP/IP communication, modeled by a random value, and times of task processing on a given host. The task processing time is equal to the task processing time parameter multiplied by a number of other tasks processed on the same host in the same time and divided by a the host performance parameter. Since the number of tasks is changing in simulation time, the processing time is updated each time a task finished the execution or a new task is starting to be processed. Having above notation, the task processing time is equal to